Welcome back and to this lecture number 19 already. Man, we're moving along. In this lecture, we're going to continue on with our PLSQL discussion. And in particular, in this lecture, we're going to take a look at functions. Should be great fun. If you'll recall, in our last lecture, we put together a little procedure that updated the suggested price of a product based on the average of all prior sales prices. It was okay at best, but what it failed to do was take into account the order quantity associated with an order, and as such, all orders, whether it was magnitude of 2 or 2,000, were weighted equally, and that really lacks a certain degree of elegance. What's the good news? It gives us an opportunity to revise that guide within this particular lecture, and we'll do so by creating a function that does the weighting, and then we'll call that function from within our previous procedure. Should work out just great, and again gives us a chance to look and learn about something new. All right, before we jump in, it's time now to pause. Download that resource material, lecture 19 scripts.txt, open that guy up, fire up developer, and let's get started. See you on the inside.
All right. If you'll recall, this is a logic we used for our update product suggested price procedure. We created this guy in our last lecture. Basically, we selected the average % discount associated with a particular product. Based on the magnitude of the discount, reset the suggested price accordingly. Actually, kind of embarrassingly simple. We basically gave the same weighting to an order of 5 as we did to an order of 2,000. Not very elegant. I suggest we take another shot at it with 2 principal modifications. First, let's recreate our current solution as a function, or at least this component of it as a function. And then let's try to rewrite that function to include a weighting factor for the number of items ordered per line item. Okay, by now this function declaration statement shouldn't really hold any big surprises for you. Standard create or replace function, then the function name in the past parameters. Only real thing new here is this next syntax, return followed by a data type. Okay. Pretty self-explanatory. I won't beat that horse other than to say the first time our code encounters the keyword return within the execution block, it's expecting an associated number and it's going to kick out at that time. Fine, we'll make that happen. All right, nothing new now until we get down to the select statement in the first if, else, and if block. Here we take the average within a single select statement instead of accumulating our variables within a cursor as we did within the procedure. This is of course just a little more elegant, although our procedure example did give us a nice look at the very common for loop cursor syntax. If you recall, that for loop cursor syntax was nice because we didn't need to explicitly open and close the cursor. The for loop provided enough information necessary to get that done automatically. If you're thinking about bad memory management, failing to close a cursor is a great one for bad memory management. Anyway, let's go with this more elegant solution for our current version of this function. All right, nothing exciting happening within the if, else if block, so let's move on to the return statement. Oh, wait a minute. Did you notice that the E is missing from within the else if syntax? I personally manage to mess that up every time I use it. Hey, Oracle, how about you learn how to spell else if properly? Anyway, on to the very straightforward return statement. It simply says, okay, I'm going to stop execution at this point and return the value in the my discount variable back to the calling select statement. All right. Before we begin testing this routine, I suggest we run this little query to know what to expect with respect to our if, else if conditionals. Looks like the only product ID with more than one order line item is 5. Grandma shine. I guess I would have expected that. Cool. let's go ahead and run our tests and see where we are with respect to our new function. Notice how a user function can be used exactly like those provided by Oracle. Just stick them in any select clause of any query. In our example here, we seem to have chosen the dual table. That makes sense. We know we're only getting one row. Product ID 1 has a negative discount, so we'll correctly return a value of 1.25. Product ID 2 has fewer than 20 rows, so we return a value of 0.95. Again, that's correct. ID 3 is again negative, so return that 1.25 as expected. ID 4 has a value greater than 0.5, but only one row, so again 0.95 is the appropriate return value. Finally, ID 5 has 20 rows and a discount value greater than 0.5. As such, the else clause will be utilized, giving us a return value of 1.1. Cool, that's exactly correct. Finally, that invalid product ID should have returned from the top row count conditional, and as such, a value of 0 is completely appropriate. Hooray! Looks like we're able to recreate our procedure with a slightly more elegant select statement. However, we are still not considering the quantity of an order, so let's do that in our next example. All right. Now let's see if we can make this thing a little more elegant by weighting our discounts by the quantity of items ordered. It should make sense that an order of 2,000 has more weight on a discounting policy than an order of 5. All right, check out version 2. Nothing new going on in this function or variable declaration until we get to this cursor. Looks like we're going out and getting the suggested price, sales price, and order quantity for all line items associated with our product ID of interest. Okay, I'm thinking that's clearly a step in the right direction. So at this point I was like, hey Rick, do you know how to calculate a weighted sales discount? No, not really. I guess we'll just have to figure it out. So how does one go about doing that? Well, if you're me, you start by analyzing the most difficult and complex record set. In our case, that's product ID 5. It's got a whole bunch of sales, and the order quantities vary from very large to very small. Let's run some analysis on that data set. Start by taking our cursor select and pasting that bad boy into developer and substituting our product ID of 5. I'm just going to copy that whole record set into Excel and start working up some formulas for a weighted sales discount. Not surprisingly, our weighted absolute discount is simply the discount times the order quantity. Similarly, our weighted percent discount is the ratio of the discount to the suggested price times the order quantity. Think about it, it'll make sense. Our overall weighted discount then for product ID is simply the sum of all discounts over the product of our total item count times suggested price. Okay? Expected answer for our product ID of 5, just about 0.2486. Cool, that'll be our target when we're testing. All right, now that we know the formulas for a weighted sales discount, we can go ahead and code that thing. Here's our cursor block and our corresponding calculations. Should be no surprises here, simple arithmetic. All right, now that we know what to expect for product ID 5, let's go ahead and run our test. Beautiful. Our discount value is 1.0, which is exactly what we would have expected for a percent discount calculation of 0.24. Values greater than or equal to 0 and less than or equal to 0.5, and we have a corresponding more than 50 items. Hey, I don't know about you, but I find that last test a little unsatisfying. What if our calculation had resulted in a value of 0.35, 0.45, 0.27? You know what? We still would have gotten that return value, but clearly it would have been for all the wrong reasons. I suggest we run another test, but more specific. First, double-click on the Adjust Suggested Price V2 name from the tree menu on the left. You'll get a new tab with a copy of the function code. Next, slide down in the code to the line just above the if my percent discount less than 0 statement and type in return my percent discount. What is this going to do? It's going to jump out of the routine right here and return the value of my percent discount instead of the regular my discount value. What's the net? I'm debugging this thing without that stupid dbms output.put line command, which I can never get to work properly in Developer, and I hate using SQL+. Now go ahead and recompile with that little gear symbol at the top of the window and run our select statement again. Now that to me is much more reassuring. Right where we wanted our value at 0.2486. Cool. Now I feel more comfortable that our function is acting properly.
All right, I'm not going to go through the details of swapping out version 2 for version 1. You can figure that out on your own, I'm sure. What you're going to do first is drop the version 1 of that particular procedure, recompile version 2 with the version 1 name, and then drop version 2. Just that easy. No big deal. Oh, and don't forget, get that debug statement out of there too. Nobody coming down the line wants to see your garbage still in their code. All right, that concludes our discussion of procedures and functions. In our next lecture, we're going to take a look at triggers, which I know we touched on earlier, but we're going to take a little deeper dive. And also packages. Packages can be very complex. We're going to just skim the surface, but we'll take a look at that in lecture 20, so we'll see you there. In the interim, you know my line. Go out there, you have some fun for yourself, but learn something every day.